In this video, we're going to take a look at the intersection wizard, which has been around all the way back to 2010 and really hasn't undergone a lot of improvements, but is still an extremely useful design tool in Civil 3D. I have a drawing started from the framework's sample data set. I brought in 3 alignments, and they're currently all as data shortcuts, so they're all data references. So a couple of things aren't going to happen. My profile locking on certain kind of intersections is not going to happen, so I'll have to go back and fix that. But this is what I want to do. We have an end goal. That end goal is expressed in this drawing, and let's just plot it in model. Take a look at what we're shooting for here. We have 2 intersections that are effectively connected together into one large corridor producing a surface. As we can see, we have a constant slope and that southern alignment. We've modified the intersection to have a couple of left turn lanes and acceleration in and out lanes going onto the main street. At our other intersection, we have a fairly straightforward, fairly simple intersection at the northern intersection. So how do we get there? A couple of little tricks to using the intersection wizard to combine and test, which is really what we're out after. First thing we want to do is we want to start the intersection wizard. It's going to look for the intersection, and it's going to look for baseline pairs, alignments, and profiles that actually have matching stuff. So out of the Home tab, go to the intersection, create an intersection, we'll let it search and look for roadways. It will make a determination about what comes first and what comes second. We'll just call this intersection, we'll call this guy south. Just keep things simple. The rest of the naming might be really important. We're going to use a relative marker so we can zoom in and out. We're tossing that to an NCS layer set up by the instant-on templates that we're using now. We got a label, and for this one, we're going to maintain the crown on the primary road. As we saw already, that's a straight crown. This could be already super elevated, and I could have modeled that corridor and got out my super elevated profile to fix things here. But we're going to skip that for now since that's not our real issue. We just want to get the horizontal control set up correctly. Next, in this piece of the create intersection box, we want to make sure that we have the right primary, and we do indeed have the right primary in this case, and secondary alignments. The other really key issue is we do not want to create the offset and curve return profiles yet. We want to get all our horizontal stuff set up properly. So let's hop in and do our offset alignments. Naming here is critical. For the west to east road on the bottom, I want to change my naming templates. I don't want the offset values set in there for either of those. So I'll change those first off. I could, of course, build that into my intersection wizard settings, which might be a good idea if I was doing this repetitively in something like a subdivision where I have lots of roads and lots of intersections. This roadway is a multiple lane roadway, and we're going to use large offsets. For the secondary, for the new road, south to north road, once again, we're going to remove those offset parameters from our name templates. Keep that stuff all straight, so I'm just doing lefts and rights to keep things simple here and not putting in that offset value, which I may want to change later. And these will leave at the stock AASHTO 12-foot level. The other important checkbox here is I do want to create those offset alignments for both the west to east and the south to north roadways, and I want to go all the way to the ends for now. and say OK, because I want those alignments. My curb returns, down here I'm only going to have 2 curb returns for right now. Intentionally going to leave those set to some default values out of my settings in my template. And now I'm just going to create the intersection. Notice, because I cannot lock the offset profiles here, and I cannot change the south to north centerline profile, my profile locking did not happen at this offset, but that's fine. I go back and fix that in the resource data, in the data shortcut data at any time. Now I gotta roll up and build my next intersection. So we're just going to build another intersection. For my profile pairs, I prefer to, where's my primary road? My primary road is going to be my west to east. This time we're going to do all crowns maintained, and sometimes it's handy to use all crowns maintained, come back, get all the geometry right, go back, erase stuff, and solve your problem that way. Let's make sure that we get the intersection name right. Go to that next critical page. Remember to uncheck our vertical control stuff. In here, I can change what my primary road is, play with those values. Again, we're going to create offsets. Here's part of the tricky part. For my west to east, I do not have an alignment. So I'm going to get rid of those offset values once again in my name templates. Do that right away so I don't mess up and make a pile of stuff that I don't want. In that case, we do not have an existing alignment, and so we want to create those new 12-foot offsets. For the south to north, we already created those alignments. We certainly want to remove the name templates anyway, just so I don't confuse myself. So systematically I get the name templates, and now I want to say yes. And what alignment do I want? So this will be my left offset, which I already made, which continues all the way through. For my right, I want to use an alignment, and that's going to be my south to north right alignment, which I already created from the other intersection. I still want to check new offsets from the start. So this will build me my new offsets for my west to east, but ignore the creation of the south to north ones. And I want to create that intersection. Once again, can't do the profile locking because of the data references, and bang, I get my simple basics. So now I have 2 fairly simple and basic alignments with the basic geometry. And now I can go about creating the horizontal stuff in much more detail. So let's hop to another drawing. So what did I do to get this more complicated horizontal control in these 2 intersections? First and foremost, I edited my curb returns. And as now we can see, I have both incoming and outgoing roads. I did some transition stuff. I'm just using real simple stuff on both of these at this point. Could get fancier, but at this point I'm just trying to get my problem straightened out and solved in terms of all the horizontal control for the 2 intersections. So as you can see, I've made incoming, outgoing acceleration lanes, etc. So one of the things I might want to do is check the supers that I'm going to need to apply on the acceleration lanes, this lane in particular. So I need to assign a design speed here. We're just going to keep this yield level. Use design criteria. I am using the 2011, and I want to keep that at 8% max, just as an arbitrary value. I'm not going to use any design check. I can certainly do that. and apply that to the design speed. So now I have design speed, so now I can actually calculate the supers that I would eventually need. It would be a undivided planar roadway. It's going to be symmetric, and I'm not going to do any shoulder stuff at this point. And we'll just do resolve and automatically resolve the overlaps at this point. And I end up with a set of super values. And that being said and done, I can now check that and see if I have any warnings. So once again, because my radius curve is 45 feet, you see my minimum radius is 38 feet. That's good to go. If I turned up the design speed and said it was 25 miles an hour, I would probably fail and need to use a larger curve radius. So all the point is, in terms of getting and developing all your horizontal control inside Civil 3D, for an intersection, you can interactively use all the other tools. The rest of the stuff is fairly straightforward in terms of what I did. There's an interesting little transition here. You notice the transition overlaps between these two curve returns are intentionally done, and I'm going to have overlapping regions between the two theoretical corridors I create from here, or overlapping corridors in the single one when I'm done. So I want that to happen, and I want that to happen at a specific station, which happens to be 300. So I'm controlling where that overlap condition occurs, and therefore I can deal with the surface building that comes out of the two intersections. My next piece is I've got to build all the slope control for all my lanes. So now we're just using the intersection wizard until my horizontal control is contained. I'm only editing offsets and curb returns. In here, I can edit the offsets and edit the curb returns. So I'm in this first panel until my horizontal is pretty much straight. I did add for this offset alignment, you'll see that it indeed has a widening, giving it an extra left turn lane. So I have two left turn lanes effectively occurring at this, just to make things a little bit sexier. So I have the stacking all figured out. I have right and two left lanes at my southern intersection. And now I want to get all my slope control done. I almost always hit this secondary road rules, check them, make sure I know what's going on. Very often I might change how far out from my intersection extents. These are calculated and applied based on what I need and other intersections upstream and downstream from where I am. Now, lane slopes. By default, because I didn't go through the whole wizard, everything says yes here. However, I don't have these, so I need to say no. And we're just going to say no. And so now we're building the slope control right and left for those. Maybe I can put a super value in. If it's all a steady curve here, I can throw a super value in and accomplish that at this point in the design as I build my vertical here. For south to north, don't have those yet either. So I need to turn those and the calculation and the naming rule. You get the naming rule based on the values in your template, whatever you want to change the crossfall to. And so we're going to leave those alone at this point and build those two. So now we got the lane slopes for the bottom, and now we need to do the curb returns. Just to keep things simple, we're going to just use simple basic default values. I of course could go back and edit all these profiles and returns, etc. So we got the slope control done for the south intersection. Now we need to do the verticals for the north intersection. Select it. Once again, just hit this box. You know what, my already made those choices and planned for those. Now we're going to do the lane slopes. My south to north, I already just corrected. So once again, we're back to, yep, there's my 2% left. My south to north, there's my right profile that I already created from the other one, from the other intersection. These do not yet have. We'll just use our default slope control, and we're done with that vertical. Curve returns, create the curve returns. Just use default values here for all four. I generally like to page through. I did do some transitioning, but we have our verticals now all done. So I hit intersection 1, hit intersection 2, went through all the vertical panel and got all it right. And now I need to create my quarter regions. And I'm going to start with my south intersection and create the quarter regions. Here I've just browsed out, picked a typical assembly set. It's all using local road, etc., and curb returns with sidewalks, etc., and we'll create all those. It'll go out, link up all the code. We're good to go, and we get an intersection. Voila, right away. Usually I like to test both intersections independently, so I'd build a separate corridor for the north intersection, but for the sake of time, we'll just now go and add the second one since I got a pretty good idea it's going to turn out the way I expect. Create this corridor regions. In this case, we are adding it back into the corridor. Notice very carefully I'm not doing any daylighting. I do not have an existing surface in this drawing. It's not necessary for me to test my intersection design at this point. And once again, we're just going to use the exact same assembly set and recreate that one, though we never created it before. Do we actually? Now I end up with one gigantic corridor. I have two overlapping regions in here. And so I got some minor changes to make my surface turn out right. A couple of things I want to do in my parameters. I want to find those regions, and that region should start at 300, which is where I decided to, where I plan to link them up together there. And my other south to north section, I want this value set to 300, so my sections or my regions are meeting at the same point, breaking at the same point, but ignoring whatever is going on horizontally and vertically beyond them in the corridor. And this will make my corridor actually work. So I end up with a surface. Now I can go up and build a surface. We're just going to call it top to be simple. We're just going to do top links, not do anything too sexy here. Rebuild my corridor, and I should end up with a surface. And notice we're using proposed contours, so I should end up with a surface and stuff, 10 triangles, making corridors where they don't apply. Good test. If you have multiple corridors being added, you want to make sure you're getting surfaces that appear in both sets. So it was a good test before you add the boundary. And now we can just use the corridor extents as a boundary. Now I want to make some stuff prettier. We'll make our corridor invisible. And we use the code set style. And we'll use this plan with road screens. Get a choice. Since we also got a corridor selected, we're going to send that back in the display order so the surfaces is on top of it. And we get our corridor, we got our surface. Now when we select it, We can play with the styles, take a look at the slope arrows, give me a good test at what's going on slope wise. What was a good test? Make sure things are looking reasonable as I go across this intersection. You can see the slopes all running. Things don't look wrong anywhere. A couple of places I may want to check stuff in my design control editor. And we seem to be generating slopes and lanes, all the lanes that look correct. So once again, grab my surface, go it back to PR corridors. Might want to do a slope analysis and all that sort of stuff. So that's how you can use the intersection wizard to speed up your design process. I thought I'd show another trick. Let's take a look at another drawing. And into this drawing, I have simply promoted all the horizontal control in here and made a couple of changes to the alignments. So the alignments, I added curves to both intersections after I'd already built the intersections. So now I can do nifty stuff like grab my roadway, shift and move. And as you can see, I can play where my intersection is and move my intersection around. Most people aren't aware that you can actually pull this kind of stuff off once you get the basic horizontal control. And as you can see, I can actually move my intersection around on the roadway. This is a sneaky way to get another intersection built or a copy of intersection using the same sort of rules. And the same is true. Let's just escape out of that intersection, grab this one, and we can move the PI point around. So we're effectively changing the geometry to come up with a different solution. And we'll pull it over to the left just to show you. You can make a lot of radical changes to the horizontal geometry and the vertical. Obviously, you have to go back and edit the verticals here, but you can move the intersections around, play a lot inside your horizontal design control once you get a few intersections linked up together.